There we go. All right, everyone. Welcome to our Friday Tech Talk. Thank you for joining us. Today we have David Meyer here with us, one of our graduates, and they're going to be talking about basically explaining DevOps. I'm sure some of you know this topic. If not, David will go over that. So thank you for being here and take it away.
Right on. Thanks, Regina. So I just wanted to talk a bit about the concept of DevOps and then give some specific tools for that you can use to implement those methods that can maybe make your life a little easier and make you more valuable as a developer or as a when you're on the job hunt. Being able to speak to these topics, in my experience, has been very important. So let's jump right in. Just a quick introduction for my journey, so to speak. So I graduated from the Tech Academy in September of 2021. I enrolled in the software development bootcamp. That was like the comprehensive, longer bootcamp. I actually got an extension for that. Ended up working a little bit longer, which no shame in that. I made a point to see it through. So graduated, and I learned a lot from that course. It really is a crash course, as many of you probably know or are experiencing right now. So if you're in that, like, keep it up. Moving on after graduation, I moved into the job search portion. There was some assistance from the Tech Academy with an advisor that was helpful, just to be like accountability and a sounding board, and to just be able to say like, hey, I put out 50 applications this week or whatever. That kind of helped me keep engaged. But it was probably about a 3-month process of searching full time. So 5, 6, 7 hours a day of putting out applications, being very intentional, cover letters, interviews, all that. It was quite the process. Eventually, I got hired in January of 2022 as a software development engineer for a company called Plain Concepts. They are based out of Spain. The United States team is relatively small, comparatively speaking, so it's been kind of cool being a part of that team. And getting some like cultural, international interactions and stuff. That's been very valuable and kind of eye-opening, really, just to get a broader perspective. So I still work in that same role, and I still consider myself a quote-unquote junior developer, even though that's not in my job title. But that's where I'm at. I am a junior. I would consider a step above a student, but I've got some seniors that I work with too that we work closely together. Constantly learning and growing. I figure if I have a week where I don't learn a new thing, I'm either not trying very hard or something went wrong. So just keep that in mind, that I'm never gonna know everything. So it's just a constant process. As I mentioned earlier, this job is fully remote, which is a just big difference compared to some of my past experience. I've worked in construction. Obviously, you have to be on site swinging a hammer to build stuff. But I also worked in retail, where you have to be on site for that too. And this whole attitude of, if you have time to lean, you have time to clean, and just kind of resetting my brain to a more academic sort of focus was quite a challenge. Feel like it's still a process, and I can speak to that more later. But so that's kind of a quick introduction for me. Let's jump into the topic. So first of all, just what is DevOps? It is a made-up word that is a just amalgamation of the word developer and operations. So it's a set of practices and principles that bring together software development and then operations. So the coding and how do we make this all work? How do we manage our workflow? How do we deploy? How do we get this to where it needs to go outside of my computer where I'm running it locally? Some key points about DevOps are that it's increasing efficiencies in the software development process through things such as communication, collaboration between your team, better integration between your different applications and tools. And then a big thing is also automating repeated processes. And I'll get to that more in a little bit. So why use DevOps? Like what are the benefits of that? Uh, First of all, you have improved collaboration and communication that I mentioned earlier. Um, there's this concept of like breaking down the silos. So instead of having each team or each member in their own silo that they're only working in, so they're working on one specific thing, they get it done. Anything else not related to that is just, out of sight, out of mind. The idea is to break that mindset of, hey, this is a team approach, this is a project approach, and DevOps can help facilitate some of that so that everybody is working towards the same goal, not just, say, the designer's only working on drawing out a design, or the person working on the pipelines is only working on the pipelines. Like it's a broad approach. Uh, there's increased efficiency and productivity. So I mentioned this briefly earlier, but automating repeated tasks is huge. This leads to less what I call like busy work, where you're just it's something that takes a lot of effort but not a lot of brain power, which is kind of a waste of time. So by automating those simple things or those repetitive things, it allows for a developer to work on more complex tasks that do require more thought and more time. Also, you get faster time to market. So by being more efficient and productive and automating things, you're able to like get your product pushed to market quicker. So get it deployed, get it to your customer or you or whoever the end user is, which translates to you being more valuable if you're working for someone else, which then translates into making more money, which, that's a great goal to push for. It's not all about the funds, but hey, if you're more valuable, you deserve to be paid more. Simple as that. You also get higher quality software with the DevOps approach. It emphasizes like continuous testing and feedback. So by doing that, you're able to catch bugs sooner, have better like alignment for where you're going, less stress and less like last minute bugs, I guess is what I would call them. So by catching these things sooner with testing, you're avoiding a situation where you run a report at the end of a project and realize you have 100 things to fix, and that's overwhelming. Another big point is a DevOps approach allows for greater scalability and project flexibility. So a big thing that I've experienced in software development is that the scope of the project's gonna change. Like it's inevitable, whether it's the customer deciding, hey, put a button here or add a page, or let's do this functionality, or if it's technical requirements that change or a certain approach is physically impossible, like you have to shift gears. So that's gonna happen. And by having an approach with DevOps, you're able to adapt to that easier by having smaller pieces that you're working with. One other big thing is the concept of infrastructure as code, or IAC. I've seen that referenced many times in my research now. And what that means is just it's representing the infrastructure components as code. So an example would be a script that would set up the configurations for, say, like a virtual machine setup. So you can just run that script and then it sets all that up. You may need a similar virtual machine for several different applications. So you can just have that template ready to go. That infrastructure is code in that sense. I don't want to get too into that because it's not entirely the purpose of this talk. But if you are interested, just research infrastructure as code, and you'll find a lot of resources on that. I have some at the end of this too. Moving on the final point, again, about greater scalability and flexibility. I keep bringing up this term of automation and automating things. One big concept of automation is what's called a CI/CD pipeline, and that stands for continuous integration and continuous delivery. So as you're making these new versions of your software, by having a process automated that performs your build, does some testing and checks, and then goes and pushes that into the, let's say, production or development environment, by having all that automated, that just goes right through. So you can test a change quickly, you can see if it works, you can show your client quicker. All of that goes a lot quicker like that. And there's a lot of checks and balances that you can set up in those two. So the idea is that by increasing the amount of upfront work that you do, you're saving time in the long run. There's also an idea of using microservice architecture, which just means breaking down your application into smaller independent services that, they can be developed or changed on their own, they can be deployed on their own and scaled separately. An example to kind of like envision some microservice architecture would be like an e-commerce platform. So, they're selling bicycles online. They may have different microservices for things like payment processing. That may be its own service. Let's say the shipping is a whole nother service. They may have a newsletter that gets sent out to everyone on the list. That would be its own microservice. And all of these could be changed or updated independently of themselves, or even debugged, which saves time and is more efficient to do this because you're not having to debug the entire application or take the entire thing down. You can just focus on that one small microservice and update or scale as needed. Okay, so moving on, version control is another aspect of DevOps. As many of you probably know, if you've gone through the Tech Academy courses, doing the live project, you probably had some experience with version control software, potentially in Azure or in Git. But just to give a quick definition, so version control is just any system that allows you to manage changes to your code over time. That's it. It just manages change. And a cool feature is that those changes are recorded and preserved. So you would have, your first iteration, your second iteration, third, all these different changes that you've made, you now have records of that, which then allows you to use an iterative approach of, okay, version 1 is just this raw skeleton. Version 2, okay, we have a new feature. Version 3, another new feature, which then also allows you to roll back too. So let's say, oh no, the newest version, something broke or a test didn't pass. We can then roll back to a previous version that is stable and work from there again. Version control also allows for a layer of accountability. So you can see who created what code when done properly. So that gives you a little bit of accountability as the developer to know, hey, my name's going to be on these changes, so I better know what I'm doing. But then also, if you have a question about something, you could see, oh, okay, it looks like Steve made this chunk of code a month ago. I'm going to go ask him, hey, what does this do, or why did you do that? So yeah, and then I talked about the rollback, so the versioning. So that's just the basics of what version control in general is, which is part of DevOps. Specifically in Azure DevOps, they have a tool called Azure Repos, which is just where it's just a version control tool. And you can store all of your code there, so you could access it remotely from any device, which is super useful. One benefit of Azure Repos is that it integrates well with Visual Studio Code, which is just a code editor, to put very simply. And then also integrates well with Git, which is what I would consider the original version control system. But this is kind of built on top of that, so it's a little more user friendly in my experience. Some of the terminal commands can be a little scary, so having a graphic interface to look at those different things is helpful. You may have seen these before, but things like Git checkout, so that's checking out a local branch, or Git push, it's pushing your local changes to a remote repository. Those are all integrated well with Azure Repos. A couple features of the repos, it supports pull requests, pipeline integration, Azure test plans, and then you can also manage which tasks are related to which pull requests. And I will get into that more shortly. So a couple more features or best practices about Azure Repos. So you can set what are called branch policies. on a different branch. So typically you would have your one main branch, and that's like the stable version of your code. You're then branching off of that, making copies, adding features, and then merging those into main. But you may have some other branches too, like a development branch that would go into a development environment for testing before pushing into production. Or you may have a situation where you have a specific feature development branch if that's required. I won't get too much into that, but the idea behind branch policies is just setting rules and practices for what's going on with the code going into that branch. You can set things like code reviews in the Azure DevOps. So things like, okay, if a developer creates a pull request, do we have required checks and balances for that? So in my organization, we require at least one other developer to look at that PR and manually click, yes, I approve this, before it can be merged. There's some other tests that need to pass too, but that's a branch policy that was implemented by our organization as like a layer of accountability, catching bugs, and also just for peer review. It's important to do that. One other thing is tracking. So if you make a pull request, and also set a configuration that that pull request must be linked to a work item that you've been working on. And I'll talk about work items briefly, but this provides like a layer of transparency for seeing what this code change, like what is this doing? Where were you spending your time? So task 1, 2, 3, 4 is related to this pull request. Someone reviewing could look at that task and say, yes, all the requirements were filled, or no, hey, I think you missed something. Super important to have all that. One last thing about branch policies is that you could set up a code style enforcement. This is similar to testing, but essentially you can enforce a particular code style, and before it can be merged, it will have to pass this test that says, hey, are you following these rules? Typically, this is done before the push is even done. So you can set up rules in the code base itself that while you're editing it, it'll throw an error if you're not following those rules. So a super simple example of one of those rules would be, let's say for the whole project, we only want to use single quotes. So typically double quotes or single quotes are both acceptable, but just one example would be, okay, hey, we're only having single quotes in this project. If you use double quotes, it's going to throw an error and ask you to change it. There's a tool called ESLint that you can set up and configure rules. It's not within the scope of this talk, but I do have resources at the end. I think it's another tool to be aware of and to know. Can save a lot of time and can kind of set you apart in, say, an interview if you know what linting is. Okay, moving on. So I mentioned briefly like work items and task management. Azure has a tool called boards, and the idea behind that is a visual representation of your task management. Task management is a huge part of my job, or really any developer or a project manager, or even I guess like the salespeople. To be able to speak to what am I working on, what am I gonna work on, and what have I done already. Workload management, like I said, so there's a visual representation of the current tasks. You can implement different rules to establish the priority. This all comes down to like the organizational rules. But like an example in our organization is that our tasks will be listed on a board, and the ones at the top, that's, hey, do this first. And then the ones at the bottom are lower priority. That helps you as the developer know what you're going to be doing. It also helps your team members know what's coming up for other people. You can also use things like comments or attachments or tags on those boards. Let me actually pull down, I made a sample board. I wanted to show you the boards that I use for work, but I realized that I maybe shouldn't share internal company documents with strangers, so decided to go against that. But this is an example of the Azure boards. So I just created a couple of sample items. So this would have, these are like your user stories, and then these are the tasks to complete that user story. So in this case, we might have a sample story to, and as the developer, you could go in and read. Typically, you would have a description here, but like I mentioned with the comments, so if I were to make a comment here, anybody else who has access to this board could then see it. I could also tag people, which would give them a notification to come back and check it, which is then, it's helpful for asynchronous communication. So maybe you need help with something, but the other person's not immediately available. By putting in a request here or a comment or a, hey, I'm blocked, someone else could come in, look at that, and potentially provide you some resources or some sort of help. There's also this attachments tag. So any sort of relevant attachments could go in here. The links shows you like so this is the user story, and it's got 2 child tasks that are down here. So at a quick glance, you can see the tasks related to the user story, which maps to these 2 tasks here. I will come back to this shortly, but just wanted to show, hey, this is kind of an example of what the Azure boards look like. Let's go back here. Yeah, and that also leads into the accountability and visibility. So you have a visual representation of what you're working on, and then you'd also see other developers, which I've kind of already spoke to that, but I think it's helpful to see what everybody's working on. And then this also supports the Agile methodology, which is really just about breaking down your larger tasks into smaller, manageable chunks. And it makes it easier to adjust and update these tasks to fit the requirements. So in this example, sample story, that's a large chunk. So that's, let's say it's like to make a newsletter component or something. So that's the whole user story is to get that done. And then broken into tasks like, okay, let's start with reviewing the design, maybe make some outlines, create the UI, add a button, add functionalities. These are all just arbitrary, made up. But if you can see these little numbers here, this is what this is also about, like the accountability and transparency. So in this case, this is just configured to have the remaining work section. So in this example, I estimated, okay, I could get this done in 0.5 hours on this. I put a sample description in here. So something on a review design task could be, look at the design. So Figma, design document, whatever. In this example, I also put a comment, and let's say like, oh shoot, like this isn't working. Tagging the project manager, can you maybe clarify something? And then they could then see that and help you get unblocked with that. Okay, yeah, that's all I'll say about that for now. So these, as I showed earlier, so the Azure boards is just a tool in the Azure suite that helps with task management. You as the developer have the freedom to create, change, and assign tasks. Like they're all arbitrary. It's all made up, for better or for worse. There's a few different views you can look at too. If you wanted to look at backlogs versus sprints. In this case, this is a view of the sprints, which I kind of prefer this view because it's more like visual. But if we were to look at the backlogs view, it's kind of broken down into every single item that needs to get done. So this may be super long and cumbersome and hard to see, but you can see the nested tasks in here. The difference between the backlogs and the sprints is that the backlogs are every single piece of work that you've captured for a project or identified as this needs to get done, put it in the backlog. The sprints are confined to the current user sprint. And just to be clear, a sprint is just an arbitrary set of time that you've determined to get a certain amount of work done. So in my case, we do 2-week sprints. So we do a plan on like a Monday for what we want to get done for the next 2 weeks. We add to the backlog, or we pull from the backlog, rather, the items we want to get done in this current sprint. So the difference is every single thing is in the backlogs. the sprints is a set period of time that you're trying to get those tasks done. And then there's a lot of other tools and whatnot too within this realm, but dashboards are one of those. So that can give you a lot of data like analytics, load testing and performance, what's called a burn down chart, as well as team capacity. So you could assign developers to different projects, assign the number of working hours per day. So, let's say we have 6 hours of development per day and you're on there for a week, you would have 30-hour capacity. Really, this is more applicable for a PM or a project manager, but I still think it's important for a developer to be aware of these things. In the burn down chart, I don't think I have, this isn't like a real board, so I don't have a way to show it. But a burn down chart shows you the difference between the estimated amount of work done, or the estimated amount of work to be done, versus how much was actually done. So let's say we had 40 hours of estimated work. We get to the end of the sprint and we only completed 30 hours. It would show on that chart the trend of, okay, the work remaining is kind of exceeding the hours that we have left as time to complete, which then could be used by the project manager to reevaluate, like, hey, are we underestimating? Are we overestimating? Did the scope increase? I'll leave it at that. But a burn down chart basically shows the difference between how much work you estimated and how much work you got done. Moving on. So these are a couple of reflections that I have just about boards. So I keep mentioning this, but like the tasks are arbitrary. Like they're made up. It's not like there's not one right way to do it. A thing that I learned is just you don't have to wait for a project manager or someone else to assign you work or to break out a user story into tasks. Really, in my opinion, you should have the independence to make those tasks or to break something down into smaller tasks that others can then view and see what you're doing. So breaking it down into a small piece. So instead of just make the landing page, you break that down into, okay, what do we need for components? What do we need for diagramming? All that. It's up to you to set that plan, if that makes sense. Just a quick example of deliberating about tasks. So let's say we're doing a peer review of another developer's work and we notice a bug while we're testing. We could either comment on that PR, and if the branch policies are in place, it will not allow that PR to merge until the other developer resolves it. Typically, I'll use that approach if it's something urgent that really either breaks the requirements or the application. Otherwise, let's say it's just a visual bug or something like that. You could then open a new task on the boards and then assign it to the relevant developer that would be responsible for it. So just goes back to the point that task management is arbitrary, but it's important. And then the disclaimer, this is just my experience with one organization. Don't take my word as gospel, please, and check with your specific organization if you do have any questions regarding that. But by and large, my experience is that it is your responsibility to delegate or to break down tasks within the number of hours that you are assigned to a project. I'll leave it at that. All right, moving on, trying not to go too long here. So moving on from repos and boards. So where are we storing our code? And then how are we managing our time? This moves into what are called pipelines. So this is how do we get that code into a working version and then host it somewhere where the client or anyone else could see it. So pipelines are just a set of steps that define how the code is built, tested, and then deployed to production or development or wherever it's going. It's just a set of steps. These are typically defined using some sort of template. A common file format is YAML. These templates just specify the sequence of steps to be executed. I have a couple of examples coming up here that I can talk through, but the key point here is that you use a template to automate this process because it's going to be repeated. You're going to build your application 100 times over the course of however many months, or you're going to continue deploying different iterations. It's unwise to do that manually every single time. Reset, but that's silly. So you can have varying levels of automation. So the whole entire thing could be automated, or you could add in some checks and balances, like an approval from someone else just to do a double check before it goes into production. One example at my organization is that changes made to the development branch automatically get pushed to the development staging environment. So as soon as you merge your pull request, it's going to auto start the build. Once that passes, it's going to go through all the steps to deploy it. We do not have this with production because we have a couple extra checks and balances there where it'll build, go through the steps, but then someone has to still go in and do a double check and manually approve, yes, this looks okay. That's for accountability, and then also just catching any last minute things, because production is kind of that is the end product. A few other things about pipelines. We've got some features for like monitoring and logging the pipeline executions. This can be used for debugging. If something's failing, you can go through and see where that error came from and then go from there. Key point of a pipeline is that it allows for faster, more reliable software delivery. I know that keeps coming up, but that's really the goal of a pipeline, is to have a reliable, faster push into the market or into the target environment. I mentioned templates briefly earlier. There's many different types of templates that you can use. One example is an ARM template, or in the context of Azure, it's an Azure Resource Manager template. And essentially, it just allows you to define some different things, provision and manage infrastructure resources and the configurations in code. It's written in JSON format, so JavaScript object notation. And then you can use it to define a ton of different things, like a virtual machine setup, or maybe a storage account for your assets, or net configurations, really whatever side of the infrastructure that you need. Like I mentioned, there are a bunch of different kinds of templates. For example, I think this is kind of funny. So there's a template called Bicep, like the arm, and it's an extension of ARM. And I don't know, ARM, Bicep, it cracks me up. But it's supposed to be more like syntax friendly and easier to read. It's a little bit simpler. But with anything, there is a learning curve. I think I have a couple examples coming up here. But just on the high level setup of a pipeline for the steps. So first of all, you have to define the resources that you need. So what are we trying to do here? Let's say we're trying to set up a storage account so that we can put assets there and then access those remotely. That could be one example. Once you've defined those resources, you would create the JSON file and define the properties of each resource. So stuff like, okay, what's its name? Where is it? What are the settings? Do we have limits? All that. And then you can use some different tools like the Azure portal, which is a graphic user interface, or you can just click through it in Azure to provision some things. You can also do it fully through a CLI or a PowerShell, which can look a little scarier, at least to me. Like having the terminal commands is like, I don't know, I want to click on a box, but it's slowly growing on me, and there's more like complex things that you can do with the CLI, but it's not really in the scope of this. Like I said, that's just one way to do it. A way that I've typically done it in the past is directly through Azure. You could do like create a new pipeline. So if you were to go here to the pipelines tab, create your first pipeline, and it would walk you through the steps. I don't have a repo. I don't have any code saved in here, but this is where you would go, and it's pretty user friendly. There's a lot of really good documentation. It is a little heady sometimes, but for the most part, the Microsoft tools that I've used in Azure have been well documented. So that's the gist of like how to set up a pipeline. Here's an example of an ARM template. The specific words and values in these key value pairs are not important in this example. The point I wanted to show with this little screen cap, I know it's small, is that it's in JSON format. So these little curly braces, these are all just JavaScript objects. So example, it's provisioning. Remember the early first step was to name and like provision the resources. So we've got like a resources block, it's got type, name, like the version of the API, the location, a bunch of other information that you would get from that subscription that you're trying to get from. I have a couple of resources at the end if you want to take a closer look. I just don't quite have time to talk totally through how, like all the ins and outs of where to get these. But the point I wanted to make is that this is an ARM template that provisions a storage account. So this is setting up a storage account. By contrast, this is a Bicep template that does essentially the same thing. It's much shorter. It seems a lot simpler. So this seems like it's an easier syntax, and it is. But this also is doing, so it's got a parameter of the storage account name, defining the resource here, defining resource name, and then those other similar things like the location, the SKU, gives you a connection string. So it's just a template that does some instructions that you can then save and repeat. The specifics inside of this template are not important in the context of this example. Just to wrap that up about templates, so there's parameters defined, so storage account name right here. So you would put whatever the name of your storage account is. There's like a resource block which defines the Azure storage resource with the specified names. So I showed that briefly. So it's got like the SKU, and you would get this from the related subscription that you are trying to access. And then the output block, like I said, has a connection string. You need a connection string to connect to a storage account. Yeah, let's just leave it at that. So template is a set of instructions on a very, very basic level. All right, so there's lots of different templates. What's the difference between a Bicep template versus an ARM template? As you saw, the Bicep files are a little cleaner. They're easier, simpler to digest. There's less boilerplate setup code. So on this one, there's more code that you have to specify each time. I'm honestly not 100% sure how this accomplishes the same as this with less words, but I'm not complaining. There's also additional features in Bicep like type checking. So if you did have a longer, more complex folder, you could specify types, which could help reduce errors, as well as just modularization of the templates, which is just a general term for breaking large things down into smaller things. So have each template do one thing and do it well. That's a good practice to have. So I will try and wrap this up before too long so we can get a couple of questions in. But just to reiterate, so key points, DevOps is just a set of practices that bring together development and operations. It's communication, collaboration, breaking down big things into smaller things. Can't really make it much simpler than that. Azure Repos is a version control / storage where you can store your code remotely and others can access it, or you can access it from other machines or other locations. Can also set up different policies for how that code is managed and how changes to that code is managed. You can do task management with the Azure boards, which gives you a visual representation of what the team is working on at a given time. It's also used to capture work items. So during your planning sessions, you could make a backlog for user stories of what you want to complete or what needs to be completed, as well as smaller tasks that can be done to accomplish that user story. Continuous integration, continuous deployment, or CI/CD, is a huge part of DevOps, and that is just the process of building, testing, and then deploying an application in any context, in any environment, and then using templates for those pipelines to automate that process. So if we know we're going to build the project every single time and we're going to run an accessibility test every single time a new version comes out, let's just have a template that has those sets of instructions, and then we run the newest version off of that template every time, which saves you time by not having to do repetitive tasks manually. I can't stress that enough, just to the amount of time and energy that can save. And yes, it does take more upfront work to set all that up. But once you have those tools set up, it saves you time in the long run. And I've been on both sides of that, where I've been in projects where the pipelines are all configured, they've already been set up, and just doing changes to a particular feature is, you almost take it for granted. It's so easy. And then on other projects where it's either a brand new project or they just don't have it configured the same way, it's definitely a pain point to have to manually do some things. Or I did a little bit of work setting up a build pipeline for a project, and yeah, like it was, I feel like I could have manually done the build quicker than setting up those templates. But after doing the templates, it's like, okay, I see now. We're you see how much time it saves. So without rambling too much, I just wanted to reiterate that those are the key points. There's a lot of benefits of using DevOps practices. It really focuses on collaboration between your team, communication, like the efficiency, the reliability of your program, accountability and transparency. So who is working on what? How long have they been working on it? Do we have any blockers? Do we need to communicate with each other to fix those blockers? You can see the progress that's been made as a project manager or a developer. This aligns with the agile methodology of constantly checking in, constantly course correcting, constantly ensuring that we're going the right way that we want to go. And then it also supports just the idea of continuous improvement. So with that constant check-in, the constant testing, the communication, like it lends itself to improving yourself personally, improving your team, and then also your organization. I think that's about it. I've got some different resources available here. I'll make this presentation available. I think, Regina, I could just send that to you, or maybe I can just link it in the chat right now. Yeah. Well, maybe. All right. So that is the end. I think it's the end. Yeah, that's the end of the presentation. I don't know if anyone has any questions, or I could look in the comments. How do I get there?
Yes, there are some questions in the chat. Let's see. Also, I'm not sure if it's because I'm on my phone, but I'm not able to see the presentation. So if you're not able to see it, let me just put my email in. Regina Y at learn. One second, my phone's being very glitchy. Oh, there we go. Actually, put it in there. Perfect. All right, on to the
Okay, here. I think I can see the comments now.
perfect.
There they are. Yep. So I'll just go through the questions in order. So we got a couple questions from Sherry. Question. So how do you ensure team member silos are broken down? Do you take turns doing different things? That is a great question. Yeah, we actually had a conversation about that fairly recently. Short answer is yes. We kind of take turns with different things. It is easy to fall into this role of, I understand XYZ, so I'm going to gravitate towards that, which if you're fine doing that, great. But it can cause you to get pigeonholed into something. Our organization also, like, we try and allow people to work on something new, like at every opportunity. So I think that kind of helps break down those silos of like, for me, I worked with another developer on some back-end tasks related to some API calls. That was something I was a little less familiar with since I stayed more in the front end. Um, but it's really just the constant check-in, the constant communication that helps you break down those silos by, at the very least, giving you some visibility into what other people are working on, so that there is more of a team approach and it's less of the, well, I got my thing done, so I'm moving on. Um, yeah, I'll leave it at that. But that's the short answer there. Follow-up question: does documentation count as code? Oh, I didn't read the whole question. Besides infrastructure as code, does documentation count as code? Not sure I fully understand the question, but documentation is super important, even just for internal projects. I found myself working, so like once a month, I have to add a new article to a particular application. And it was kind of a pain point for me to, each time I'd come back to it, it'd been just long enough to where I kind of forget about it. So I ended up making like a quick guide in the documentation for that project of, hey, here's the 10 steps to add that new article. Now I can just go back and look at that. So I wouldn't really call it code or infrastructure, but it is a key part of the project, and I would say that that aligns with the DevOps methodology. So great reminder to document your own work and also seek out documentation for other things. Like, it feels like homework to me when I have to make documentation because it's not the fun part. It's not the coding and all of that. But yeah, that's a great point. Let's see. So another question says, what does PM and ES lint stand for? Kind of two different things. So a PM in this context is just the project manager. Uh, and that's someone who, as the name entails, manages the projects. They may be a little less technical than a developer, but they're typically the go-between between like the customer and the development team. I think another similar term for it would be product owner. We don't have those in my organization. We just have project managers or PMs. They're really responsible, in my understanding, they're responsible for like delegating, so assigning different developers to different projects, doing those check-ins to make sure that the hours are like aligning with your estimations. Uh, and like I said, they talk with the customer and then relay things back to developers so that developers aren't constantly in meetings about those sort of things. All right, move on. Okay, here's a question from Jacob. Says, searching for a job and to make myself more hireable, I have received my AWS Cloud Practitioner certification and studying for the next, which is an architect certification. What certifications, if any, would you recommend a recent boot camp graduate achieve? Struggling to stand out. Yeah, no, that makes sense. How do I say this? I think certifications are very important and they can help you stand out. Um, and I've taken a few certifications too, particularly through Microsoft. So I've done a certification on Azure DevOps and like Azure. I think it's, I'll have to find the actual course, but so I do have a couple certifications that are relevant to what I'm doing, but I pursued them because they were relevant, not I didn't get them and then find a job in that field, if that makes sense. So honestly, any sort of developing certification that you can get would be helpful. I would rank the importance of what can you learn and get from this. Like that should be above how good does this look on my resume. and maybe I'm biased as someone who is employed currently, but just having that knowledge is more important than the little sticker. That being said, like fantastic job doing the AWS certification. It's kind of a similar service in my understanding. So it's like Amazon's sort of management service for all of that. And I haven't really had a good opportunity to get into it. But I guess to close that out, my piece of advice would be if you've done an AWS certification, continue building on that and being more, so like you mentioned, the architect one after that. So like keep building on those to then have this good foundation. And then once you feel like you have one particular tool understood, then you could maybe look at alternative tools like Azure DevOps or I think Google Cloud has a similar thing too. So it really depends on where you're trying to go and what you're trying to do. But the key point is to find what you can learn from that. Yeah, I'll leave it at that. I'm talking in circles. Right, let's see what else we got here. Mouse is dying. All right, another question. Where/how would you recommend getting further experience if you don't have it directly working with a company? Are there mock project examples, Discord channels, open source, etc.? Specifically referring to the Azure programs. The short answer is yes. There are those sorts of things available. I would look for open source projects. That's one way to do it. I have a link in here, I think, the Azure DevOps Quick Start Guide, and then also the Working with Git and Repos in Azure DevOps. It's a Udemy course, or I think that's how you say it. Yeah, Udemy course. That can give you some options for, I know I'm presenting, stop, sorry. Give you some options for how to practice that. I've kind of fallen away a little bit from these, but there are no shortage of Discord groups, like different meetups. I would recommend just searching on either meetup.com or in Discord, like looking for software development groups. One group I was a part of was doing they were like building a website just for the sake of helping new developers like figure things out and have that real experience, because it's hard to teach some of those things, and there's some issues and errors that come up that are just, they're hard to anticipate. And how do you try and proactively guess at what every single issue is going to be? So the short answer is look for open source projects that you can contribute to. And then also just search for software developer groups like on Meetup. I've met a lot of really cool people through that. And some that I don't really want to speak to again, which is fine, but just you got to put yourself out there and look for those groups and ask, how can I be a part of this? There's a program called, well, I did it when I lived in Hawaii, but it's called Code for Hawaii. And I think that there's also one for like every state. Like I think there might be a Code for Portland meetup. So I'd recommend looking into that. It's a lot of volunteer based, I don't know what to call it, like just civil work or things. So like, for example, in Hawaii, they were making a website for like disadvantaged like disadvantaged people to find resources for like voting or other things like that. So it's kind of a way that you can give some help potentially, and then also get some assistance with web development. So I'd strongly recommend looking for those meetup groups if you have not already. Let's see. Yeah, and there was a question about Udemy courses. I do have one or two linked at the end of this. I'd recommend checking out. They had really good reviews. I have not personally taken those, so take it with a grain of salt. But yeah, there's no shortage of like Udemy or online courses that you can do mock examples with. Okay, let's see. My mouse. Any other questions? All right. Name or a question from, I hope I pronounce this right, Serengeti. So they say, when you started at your new job, did you get any additional training or only what you got from the Tech Academy? Uh, Great question. I didn't necessarily get like technical training directly. It's a lot of indirect stuff. Um, the short answer is I just came in with what I knew from the Tech Academy and what I knew from like coding practice that I had done and different like applications that I had built just for practice and like portfolio stuff, like a weather app. Um, so there was a pretty big learning curve. Like I came into that job with the knowledge like on both sides. Like I wasn't pretending to be something that I wasn't. Like I let them know like, hey, like I'm a recently graduated student. This would be my first quote unquote real job. So they knew that going in, but it really kind of was a little bit of trial by fire. Not in the sense that they just said, good luck, figure it out. But all that to say that the learning and training that I got was from me asking about things. So yes, I had all my onboarding and all those usual things where you learn the processes, but paired programming with some senior developers was probably the #1 way that I learned. With a close second being like just reading documentation online and figuring stuff out. But if you do get a new job at a new place, I guess regardless of your experience, but especially if you're new, don't be afraid to do paired programming, which just means programming together. So either you're the one typing and you have like a screen share and you have someone else watching you and you can ask questions and do different things, or the other way around where someone else is the one doing coding and you're asking questions or they're showing you how to do something. It is uncomfortable. At least it was for me to go in with an almost stranger online and you see each other and all that and having to code and not know like, oh, where do I put this variable? And it like feels like my whole brain just leaves when that happens. But I would highly recommend that establishing some kind of relationship with a senior developer and then doing paired programming, even if it's just for 15 minutes. Incredibly helpful. And you'll learn things that you didn't know that you didn't know. Yeah, leave it at that. Looks like we're just about out of time.
I was just gonna say, I know you have busy Fridays, David.
Yes,
And there's
so
quite a few
seeing if there's
questions.
any other like crazy questions. So yeah, okay, I do need to get going soon, but let me
Oh,
put my LinkedIn in the chat. Just if anyone wants to connect, I would love to chat with you.
all right,
Share this
great.
here.
Also, thank you so much for presenting another informative talk as always. If you
Yeah,
guys want
thanks
to
for listening.
put this back, either it will be posted later tonight or early Monday, and it'll be on our YouTube channel. And let me share that link again. It should be under the Tech Talk playlist, so check it out. And then, of course, next week we also have another Tech Talk, as always. And here's the link for that, so check it out. Yeah, and David just put his LinkedIn in there, so feel free to connect with him and ask your questions in there. Anyhow, I hope everyone enjoyed today's Tech Talk. Again, thank you so much, David. And I hope everyone has an amazing Friday night. And I'll see you guys next week.
Right on. Take care. Thanks again, and look forward to talking to you soon. Thanks for the opportunity. So yeah,
Of
bye.
course. Thank you so much. Bye, David.
Bye.
Bye, everyone. Have a good weekend.